Let's take a look at a few more graph transformation examples. So this first one, so what function do you get when you reflect f of x equals 1/2 to the x over the y-axis? Okay, so how do we do this algebraically first? So we think about reflection over the y-axis. We should have a negative appear. So reflection over the x-axis, we have a negative appear, but the negative appeared out front. Instead, when it is reflected over the y-axis, we have a negative that gets put as close as we can to x. So I want to have this function, say g of x is equal to 1 over 2 raised to the negative x. So this is what the function looks like. Now, you should remember a few things about negative exponents. So if you think about when an exponent is negative, so if we think about, say, 3 to the negative 4th, what do you do with that negative? That negative says you want to put that on the bottom of our function, right? So you want to, this wants to become 1 over 3 to the 4th. Or vice versa, if you had, say, 1/3 to the negative 4, that means now we're going to flip this. We want to put this to the top. So we have now, this is going to be 3 to the 4th. So we have these negative exponent rules that we can use to be able to flip things from the top to the bottom while still keeping the exponent. So we will use that in this example because now when we want to flip this to get rid of the negative, this becomes 2 to the x. Okay, so what we've done is that I've said that 1/2 to the x, if I reflect it over the y-axis, I get 2 to the x. If we look at why this is the case, remember, this was the function of 1/2 raised to the x. But then the function that we drew for 2 to the x looked like this. So 2 to the x, if you reflect this over the y-axis, you get 1/2 to the x. You take 1/2 to the x here, you reflect this over the y-axis, you get 2 to the x. So you have this really nice property of exponential functions. When you reflect them over the y-axis, you basically have this reciprocal property of, say, 1/2 to the x is related to 2 to the x. The same way that 1/3 to the x would be related to 3 to the x. So if we take a look at the next one, if we want to look at f of x equals 4 raised to the x plus 3, it's shifted 1 unit right. Okay, so if we think about it again, graph transformations, shifting right, that means we want to do something to the x on the inside. When we do our vertical things, that's when we do things to the outside of our function. Here we're doing it to the inside, and our inside now is the exponent. Shifted 1 unit right, that means I want to subtract 1 from x. So this becomes g of x is going to be 4, and then wherever the x was, I now want to replace this with a -1 plus 3. So as close as I can get to the x, I'm going to put the graph transformation of shifting right 1 unit, which is going to be subtracting 1. Now I can simplify this as being 4 times x plus 2. So that is my function. G of x is 4 to the x plus 2. Okay. Now this one, if I have 1/2 raised to the 1 minus x, it's shifted left 6 units. So now if we're shifting left 6 units, that means I want to add 6 next to x. So we'll be careful. Because if you try this on your own, which I suggest you do, if you try this on your own, you might make a mistake. Because what I said with these is as close as we can to x, I need to apply this transformation. So that means wherever this x was, I want to shift it left 6 units. I want to add 6. Now the reason why this is tricky is because the negative is on the outside, so I have to distribute this negative when I simplify it. So I get 1/2 raised to the 1 minus x minus 6, or in other words, this function is 1/2 raised to the negative x minus 5. So this is my function that I get from shifting this 6 units to the left. So hopefully this maybe helps clarify some of the tricky examples that you might be facing. The other graph transformations that we've seen before still apply. If you want a vertical stretch by a factor of 7, you'd multiply in the front by 7. you want to do a horizontal stretch by a factor of 2, you'd instead multiply by 1/2 next to x. So all the other transformations just work very much the same as long as you're careful with how you're doing it.